Yeah? Memory. This is your memory block. Yeah? May be divided into numbers of partitions. Unequal. Yeah, unequal. What do you mean by unequal? The size of it. Yeah? Maybe this one is 400K. The other one will be 250K. Yeah? The memory. Yeah? And the partition sizes are set when the system is initially started. Yeah? When you start booting your computer, the partition is already there. Yeah? First initially started, and when the memory allocation decision is made before the actual amount of space needed. Okay, what does it mean by statement 1 and 2? Is that when partitions are divided, are set initially when the computer boot up, it refers to that the size of partition does not reflect to all the programs that we run. Yeah? Partitions are divided first, then only you start running your programs. The partition will divide it first, then only you are going to open up your Microsoft Office. Yeah? You maybe want to look up into Google. Yeah? Then only your activities will go. Yeah? So, when a job arrives, for example, when you want to doing your assignment, yeah, in the office, yeah, when the job arrives, it can be put into the input queue for the smallest partition large enough to hold it. Yeah? Since a partition is fixed in the scheme, any space in the partition not used by a job is lost. Yeah? The environment is that scheme, yeah, memory load up first or being divided first, then only your job comes. Yeah, job 1, job 2, job 3. Yeah? Okay, how the environment is, how does the computer want to make sure that each job or each activity will slot into suitable partitions. Yeah? That is the environment. Yeah? Why? Because the history or the traditionally, your memory is divided first. Yeah? The memory doesn't know that maybe job 1 only requires 50K. Yeah? The memory doesn't know. Yeah? That's why the strategies or the technique is applied, yeah, during scheduling or during process management. Yeah? Okay. The major advantage in fixed partition is simplicity. Yeah? Is simplicity. However, why is it simple? Because it is straightforward. Yeah? Okay. However, the disadvantage of sorting the incoming jobs into separate queue is when the queue for a large partition is empty, but the queue of the small partition is full. Yeah? Let's look into the. Okay, this is an example of diagram. Yeah? Fixed partition, memory management. Okay, we have the bottom part is the OS, then only partition 1, partition 2, partition 3, and partition 4. Yeah? The size of partition is already divided. Yeah? The size of the partition is already divided by who? By your computer. Yeah? By your computer. Okay, these are the examples of job. Yeah? Job 1, for example, job 1, job 2, job 3. Yeah? Multiple input. Yeah? Why? Why is it multiple? Because remember that your computer can do multi-programming, right? Multi-programming and multitasking. So it's going to be more than one task or one job at the same time. Yeah? Okay. for fixed partition, remember, for fixed partition technique, okay, first job arrives, it will slot into the first partition. Yeah? For first fixed partition, it is fixed and it is simple. Yeah? Simple. First job arrives, we slot into the first partition. Second job, we slot into the second one. Third, we slot into the third one. That's why I mentioned about the internal fragmentation will occur. Yeah, that's why internal fragmentation will occur. Maybe, okay, if you look into this one, for job 1, 2, 3, 3 tasks are there, but the size of the partition is smaller compared to the second job, right? Yeah? Only one task and slot into large or bigger size of partition. Yeah? That's why fixed partition is simple. However, internal fragmentation may occur, whereby fragmentation will, whereby there's going to be space wasted. Right? Is clear? Okay. For single queue, yeah, for single queue, previously is multiple queue. For single queue, okay, it will divide itself, yeah, into all the partitions. Yeah, it will divide itself into all the partitions. That is fixed partition. Yeah, example of fixed partition. Okay, we have 4 processors with different sizes, and the partition, okay, is also different sizes. Yeah, how does it apply to? Okay, okay, P3, okay, P1. Yeah, look into P1. P1 we slot into, this is 30K, we slot into the first partition. Yeah, first partition here. P1 we slot into first partition. And how many space are wasted? 70K is wasted. Right. And P2 we slot into, P2 needs to wait. Why? There's no partition can slot. And P2 needs to wait. And your memory manager will go to the next process, P3. Still need to wait. Yeah? There's only this partition 1. However, the first process has occupied this space. And it will go next to P2 is whole. Go into, next will be P3. P3 will also hold for a while. And we'll go next to the P4. P4, can you slot into any space?
Yes.
It will go into partition
2.
Alright. Okay, partition 2. Yeah? P3 must wait even though 70K of free space available. Where? In P1. Okay. Where process only occupies, okay, the jobs are allocated based on the basic first available partition of required size. Yeah? The theme or the objective for fixed partition is first occupies only the first available partition of required size. So in this case, P2 and P3 needs to wait until P1 completed, then only P2 will go into P partition 1. P2 completed, then only P3 will go into partition 1. So, simple, however it will take longer time. Right? Okay, this is another example of Okay, this is an example of fixed partition. Okay, it will be process 1, busy. Busy refers to occupied. P4, busy, occupied. P2, busy. However, the P3 is free. It's not the partitions in your memory is not fully being used. That's why occurs with internal fragmentation. Okay, advantage on disadvantages of fixed partition. Okay, the advantages is simple, and allow several programs to be in memory at the same time. More flexible lah. However, the disadvantages is internal fragmentation. Whereby partially of your partition is being used by a program. However, the remaining will be waste. It is just there, not being used. Okay, the next one is visual memory. When you talk about visual is not really in your RAM. It is created when needed. Visual memory is only created when needed. Created by your memory manager. It's only created when needed. It will split up a program into small modular pieces. A technique allows your processor to execute. If that may not be completely in the memory. The advantage is the program can be larger than the physical memory, can run more applications at once. If your main memory cannot entertain all the jobs, visual memory can help. Visual memory will support your main memory, can run larger applications with less real RAM, and of course you don't have to buy increase your RAM. However, the disadvantages of visual memory, since it is visually, it will cause your applications to run slower. It will cause your applications to run slower. Why? Because it is created only when needed. It is only created when needed. When your RAM is really in bottleneck like sardine, we cannot go anymore. So visual memory will support, will help. It takes more time to switch between applications. When you talk about switching applications, for example, when you want to swap your memory, memory swapping, less drive space for your use, and it will reduce system stability. Why? Less hard drive space. What do you mean by that? Do you have any idea? Less hard drive space. Okay, the concept of memory swapping macam mana? From main memory to hard disk. Hard disk is secondary. Will use up your hard disk. Hard disk will become your visual memory. That's why your hard disk will be lesser. It is being used by it is to help your RAM, your processor. Okay, visual memory structure. It is the second component of visual memory consists of feed over and above real memory capacity. Physically stored on external paging device and contains the application program. The selected pages, it happens, the selected pages are swapped between real memory or your main memory to the external or your secondary memory. Okay, another concept is paging. Paging. Paging is when you want to relate is here. Okay, this one. This is one main job. It is divided into modular or task. Okay, the task or your the task can be either in paging or segment. Okay, job 1, job 2. Okay, this may be okay, this may be when you want to do this fragmentation. This is one main activity, fragmentation. And this fragmentation or can this. Okay. One main activity is divided into job. Job 1, job 2, job 3 maybe sampai several jobs. Several jobs until this fragmentation is complete. And 100% is fragment. Okay. The job. Okay, remember I talked about your job being divided. Your process or your activity being divided. Divided into modular. Modular program. Modular program. This can be either in paging or in segmentation. This can be either in paging or segmentation. Either. Who decided? It is decided by your memory manager. Your modular, your job can be either in terms of paging or segmentation. And the concept will be, if the job is being paging, if the job is in the concept of paging, he will slot into your memory. If your job is in the concept of segmentation, he will slot into your memory by using fixed partition memory management. The same thing. Only this one can be either in paging or segmentation. Similar to other jobs for your segmentation. Your main activity. Okay, in paging, okay, a program is broken into fixed length of pages. Pages. Ada buku You have books in pages. Your main one book is your recommendation. Divided into pages. A page is small. Mainly maybe between 2K to 4K. The program pages are loaded into non-contiguous memory. Non-contiguous is not continuous. It's not continuous. Non-contiguous. Not continuous. The address for paging consists with a page number and a displacement. The address. The concept will be the address consists of two parts, a page number and a displacement. Okay. This is an example of your job in paging. Okay, this is your memory. Okay, for example, your paging, your job in paging will consist of page number and replacement. Replacement is, for example, page number will be starting with 0, 1, 2, and the replacement will be the address. Page start address plus replacement equals to absolute page address. It equals to that complete lah. In one paging consists with page number and start address. Alright, for example this one, A memory, page 0. Page 0, the replacement is first 100 bytes. This is the page number, this is the replacement. Complete address consists with page number and replacement. Non-contiguous. Non-contiguous technique. Non-contiguous, you don't it doesn't care which page frame you want to slot into. Non-contiguous. For example, page 0 will slot into the page frame number 8. Why not 1? Why not 2? It is a non-contiguous. It depends on your memory. Page 0 slot into page frame number 8. Page 1 will slot into page frame number 10. Page 2 suddenly slot into page number 5. Non-contiguous. As long as your task complete. That's the main concept. Banyak the advantage non-contiguous. If it's non-contiguous, it is faster. It doesn't have to wait until one process complete, then only it will slot into that space. It is non-contiguous. Any space that it wishes to. Since it is small, between 2K until 2 to 4K, it will mostly slot anywhere. Slot where? Slot in your memory. Slot into your partition, memory partition. For paging, external fragmentation may occur. For paging, external fragmentation may occur. For fixed partition, internal fragmentation may occur. For paging, external fragmentation may occur. However, internal fragmentation happens, however, only at the last page. The next one is segmentation. This one, job either in paging, small size, can be in segmentation. Allocate, non-contiguous. Fixed partition, contiguous. From P1 complete, then only goes to P2, P3. Fixed partition is contiguous. Paging or segmentation is non-contiguous. Non-contiguous is anywhere. It will go into. Divided into independently addresses and segments and stored in non-contiguous. Non-contiguous number. Segmentation. Here with the address, we start off with page and also the replacement. For example, segment 0, the start address is AAA 1, 2 with the different independent address. Segment start address plus replacement will occur with absolute segment address. Example. Alright, this one, this is segment 0. Segment 0, displacement is from 0 until 3, 4, 9. It is the size is 350. Betul ke? Betul ke? Starting from 0 until 349, the size of segment 0 is 350K. Class, betul ke? Yeah? Alright. Okay, segment 1, the address or the displacement will start from 0 until 199, and the size is 200K. For segment 2, 0 until 99, the size is 100K. Larger than paging. Yeah, larger than paging. Paging is between 2 to 4K. Yeah, for segment, it is larger. Yeah, larger and okay. How does it do? Yeah, non-contingent. So in your memory, segment 0. Yeah, segment 0. Memory address is 4000. Yeah, we will go into 4000. Yeah, the address is 4000 and will slot into your this space. Yeah. For segment 1, the memory address is 7000, and your memory manager will find starting from 7000, and it will slot into segment 1. Yeah. For 99, okay, since there is no address, so needs to wait until the memory manager puts the address. If not, it will slot anywhere. Yeah, where it can fit. Yeah, that is segmentation. The concept is the same. Paging and segmentation. It is the same. The difference is only that paging, the size is small, the segmentation is larger. In a non-contingent way. Yeah? Okay, another example. Segment 0, 1, 2, 3, 4. Yeah? You have the limit and the base. Yeah? This is segment 0, 1, 2, 3, 4. Yeah? The limit is 1000, with the base is 1400. Base refers to the address in memory. Base refers to the address in memory. The limit is refers to the size of your segment. Yeah? Okay, base is 1400 here, right? And the size for segment 0 is 1000 KB. It's slot into this part, physical memory. And for another example, in segment 3, the base is 3200. Address here. Yeah, we slot into segment this part, this partition with the limit or the size is 1100. Yeah? For segment 4, base is 4700 and the limit is 1K. It will slot here. Okay. In the memory, if you look non-contingent wise, so segment 0 is as above, segment 1 is below. Yeah? Who chooses it? Your memory manager. Yeah? Okay, usually, yeah, in questions or your examination, it will ask you to draw this one based on the table, or based on this diagram, it will ask you to draw or write up the table for SMT, segmentation map table. Yeah, usually similar to the page. This one, page map table. Yeah, it will give you a table. Yeah, for example, this one. Yeah, job page number, page frame number. It will ask you to draw this part and this figure. Yeah. Okay, from this one, page number 0, page frame number 8. Job 0, page number 0, page frame number 8. This one. 8. This one? This one. 8, page frame number 0, job 1 with page 0. Okay, job page number 2, page frame number 5. The diagram would be like this. 5 and job 1, page 2. Yeah? Job 1, same job divided into pages. Yeah? Same job divided into pages. Alright, this one dah. Okay, because the segment are different sizes, the displacement must be verified to ensure it isn't outside of the segment range. Yeah, it isn't outside of the segment range. Yeah, since your partition is this one, segment is different sizes, kan? Before you go into this one, for example, this segment number 2, if there's no address, it is need to be verified first. Yeah, verified first. If there's no space, your memory swapping will occur. Memory swapping will occur. Okay, fast. Any question? Banyak question. Did you read before this? Okay, take 5 if you have any questions. Innovation. In part 1, what have you learned just now? Contiguous and non-contiguous technique. Okay, if the question asks you state one type of contiguous allocation, field partition. If non-contiguous allocation, it may be paging or segmentation. Yeah? Okay, next. Saya nak go fast ya. Sebab dah terus masa. Okay, system resources. System resources. Okay, all your computers have resources. Resources, for example, your hard disk is a resource. Power supply is a resource. Okay, for resource, system resources, any physical or visual component. With limited availability within a computer system. For example, okay, type of system resources is your CPU time, your clock. Your clock to process the signal. Signal in your chip or your motherboard. It is to do multitasking. CPU time, the main function for CPU time is to allow multitasking occurs in your computer. Multitasking is done by your processor. Okay, relate to the types of devices. The relationship. Okay, CPU time conduct multitasking. Multitasking runs smoothly by algorithm. Scheduling technique, algorithm. The partition management, how it does either non-contiguous or contiguous. Why? Because it will all reflect to your processor. They are executed concurrently in overlapping time periods. Concurrently, overlap. At the same time. Instead of sequentially. Instead of by sequence. It does not however comes first. For example, in a bank, A comes first, B will go after A. It's not that. It will overlap. The task share common processing resources such as CPU and main memory. It will share. Okay, this is one type of multitasking. This is network, the view video, browse, multitasking. Happen concurrently, overlap. Okay, type of is memory. Memory is it will conduct memory management related. CPU time with memory. Managing memory. Okay, this is critical to any advanced computer system when more than single process may be underway. Underway to maybe arise. At any time. Okay, another type is system resource. It is a memory, secondary memory. Alright, you have network throughput. Allow network, you can search for share printer. It is also a resource. And you have power management, theoretical power. It's also a resource. Without power, your computer cannot be you cannot switch on your PC unless you have a battery. Your battery is your power resource. Okay, external devices. For example, peripherals. What are the types of peripherals? Can be input or output or even storage. Input, mouse, keyboard. Output, LCD, monitor. Okay, storage, hand drive. Peripherals. Okay. In human, this is the diagram here. For human peripherals, we have, this is your processor kan? Processor, your brain. So ada processor lain. Ada processor lain ke human ni? Hati. Hati ke processor, proses. Dia proses information, sensor. That's why when a person is brain dead, he will become a zombie. Okay, that's why a zombie is brain. Okay, brain, okay, sensors. This is peripheral for human. We have eyes, ears, skin, skin, and we have ability to voice out. For hardware, this is input, this is output. This, okay, for example, input, keyboard, mouse, gamepad, input into your computer processor and will be displayed in the output, or speaker. Okay, this is hardware. For software, for example, you have the OS. This is Linux, and compared to this input devices, the process or the information will go into the kernel and be processed by your programs or your configuration. And this, in this, where memory management happens at sini. And will be displayed, or the outcome will be the output. Okay, input-output operation. Okay, input-output operation relates to this one lah. Input, process, and output. By who? By the devices or your hardware. Okay, several definitions of process. These are the resources required to be processed, in order to for your task or your program to run smoothly. There are several definitions of process. A program in execution. A program in execution is running. And asynchronous activity. Asynchronous happens anytime. This one, for example, our environment is synchronous. The same time. Asynchronous. When you submit your assignment through CDOS anytime. Asynchronous activity. Entity to which processor are assigned to where? To the processor. To assigned to based on your memory management. And the dispatchable unit. You can dispatch it into several tasks visually or logically. Okay, in process, since the definition can be either a program in execution and the activity is asynchronous and depends on the processor and is modular. You have the concept of process state. Process state. Sem 1 beri prostat kan? Prostat. Okay, in prostat you have the ignition will be the start kan? Start. Okay, from start usually when it is related to come wake up early in the morning. Yeah? Start. The next one will be
wake up. Input.
Input. Input. Okay, input apa inputnya? Output ke?
Input.
Okay, wake up early in the morning. What are you going to do? Maybe you go into the bathroom, for example. Yeah? Bathroom. Okay, bathroom, and after that, maybe you want to take your breakfast. Yeah? Yeah? And several processes. Okay, maybe suddenly you feel lazy. Lazy ke? Huh? Lazy? Huh? Either if yes, yeah, if yes, go back to the mana-mana lah. Yeah? Go back, luping. Takkan baku kan? Okay. Lepas tu sakit perut kat sini kan? Okay, if not, then you may proceed to other type processes and finally end. Yeah? Okay, similar to daily life. Yeah? Or anything. Yeah, anything that you want to do. Processes. Yeah? OS also have processes. Yeah? Okay, in your handphone. Yeah, handphone. When you want to run a program. Yeah? Okay, for example, this one. Okay, this one is a process that is being pulled. Yeah, pulled in your handphone. Yeah, or your machine lah kan. Similar to your who allows this? Yeah, who allows this? The process flow lah. Process flow allows your programs or your applications to be hold for a while at the back ni. To be hold. Yeah. If you want to run, yeah. For example, okay, this one is in running state. Yeah, running state. If you want to hold it, just pause it and go back to the next program. Yeah, this is a process. Yeah, who allows it? The process flow. Yeah. Okay, the main processors. You have a new. When you want to start a new process. Ready. Running. Waiting or terminated. You have new, ready, running, waiting or terminated. Okay, new. Yeah, new. Start lah kat sini. Yeah, start. The new process is in stage of being created. Okay, this is a process to go to the class. Yeah, a lot of things happening in between. Yeah, a lot of things happening. Yeah, ready. Yeah, the process has all the resources available that it needs to run. However, the CPU is not currently working on the process instruction. Okay, new, ready. Ready. However, it is not being executed because maybe job 1 is currently running. Job 2 needs to wait. Yeah, not ready. The CPU is not ready. Your job or your activities is ready. Okay, running. The CPU is working on the process instruction. Yeah. For example, if job 1 is working on. Waiting. The process cannot run at the moment because it's waiting for some resources to be available or terminated when the process is complete. Yeah? Okay. New. Ready. Yeah? After created new, it is ready. However, it is still not being executed. Only ready. Yeah. In a bank, you have received your number. However, your number is not being called. And you have received your number ready. And after your number is being called, then you are in running. Yeah. If suddenly something happen, the system is offline, your process is being interrupted. Yeah? And you are back into ready. Right? Okay, the other person, yeah, if running or needs to wait, yeah, input, output or even needs to wait, it is in waiting, and in waiting phase, it will go back into ready. Waiting, in order to allow your process to run, you need to come to the ready phase, then only it will execute or run. Completed everything, then your process is terminated. Yeah? New admitted, you get the number, you enter the bank, you receive your number, you are in ready. The counter ready calls you, you are in running. Something system offline, you are being interrupted. Yeah? If the other person, your mom, yeah, already after in the counter, but need to wait for the manager to come in, maybe, yeah, she is in waiting, yeah, and after the manager arrives, she will waiting and ready, and if her name comes up, and she runs again, yeah, in execute running phase, and after you and your mom completed, and it is terminated. Simple, right? Huh? Okay. For this whole processor state, you can highlight three important states. It is in running, ready or block. We have there states as in new, waiting and terminated name. Yeah, is there. Yeah, for example, running ni here lah kat sini. Yeah, running here, ready kat sini. Okay, terminate block kat mana? Waiting and terminated tak? In waiting je, sini ya. Okay, in ready and block, yeah? Ready and block, yeah? Ready and block list. Okay, consists of ready processor, ready to be called, your name to be called, is maintained in priority order, yeah? If your number is 007 and your mom's number is 009, you are in higher priority based on the number, kan? Huh? Okay, the next process to receive the CPU is the first process in the list. Yeah? Okay, for block list, consists of block processors, normally unordered. Why block happens? Because suddenly, yeah, in concept of OS, your job 1 occupies everything in the memory. So the other job needs to wait. Or job 3. Job 3 occupies the largest. Job 2 needs to wait. Yeah? Okay. Running. Ready dulu. Ready. Everything clear in memory partition. Dispatch. Either in contiguous or non-contiguous. Yeah. And suddenly time run out. Yeah. Takes a lot of space. When you want to download YouTube, takes a lot of space. Yeah. Printing needs to, your documents needs to be printed. So it is blocked. Yeah, blocked. You cannot print if based on queue number, you cannot print your document unless you have finished download YouTube. Yeah? To prevent this, that's why developers produce another concept of strategies. Strategies algorithm. A lot of strategies algorithm, for example, you have people, first in first out, or you have based on priority, or you have another concept of based on size of job. If the job is small, it will run first, even though it arrives late. Yeah? Okay. In process control flow or PCB contains ID number, pointers, register, state, the list, and the status. For interrupted, and now you can read. Event that change the sequence in which a processor executes instruction. Interrupted happen when an event is being changed. The sequence event is changed. If your process is being blocked or interrupted, CPU scheduler will start. CPU scheduler will start its job. CPU scheduler, either in long-term scheduler or short-term scheduler. Short-term scheduler very frequently. Long-term scheduler invoke infrequently. Based on minutes or seconds. Control multi-programming. Multi-programming. Describe either in I/O bound process, spend more time doing input-output. For CPU bound process, spend more time doing computation. Ini you can read Ini sejarah scheduler. You have the long term or short term. Long term, short term divided into either preemptive or non-preemptive policy. Resource. One of the resources is power, kan? We have power, resources. System resources. For who? For your computer lah, kan? Why you really need resources? Because computer can do multitasking, multi-programming. Kalau design data apa? Multi-everything. Awak tak ada? Multitasking, multi-programming. Cooling. Itulah konsep dia. Cooling, buffering. Jemput chapter kan? Ingat balik. Resources. When you have resources, you can do a lot of things. Increase or boost up your PC turnover. Resources, one of the resources is your memory. Memory, for example, if you have 1 gig of RAM, you want to run lot of things, and at the same time, maybe your computer is doing at the back, this fragment or scan disk at the back. And a lot of things happening. For main memory with the size of 1 gig to entertain. That's why the terms of memory swapping happen. To help your main memory. Memory swapping is being helped by your hard disk. Memory swapping. And in memory swapping, before memory is being swapped, you have the concept of partition. Partition can be either in string or paging ataupun segment. Fixed is contingent, non-contingent. Okay, after that what have you learned? Okay, baru masuk ni kan? Processor tu mana? Sini lah semua ni. Processor ni. Ni adalah processor. Ini adalah processor. Okay, in processors we have the flow kan, dia state kan, ada state apa? New, ready, lagi run, lagi wait. Alright, tu. Okay, important thing. Okay, you have the this one ready, run, and waiting or lock. Okay, for ready, run, and block. Kat sini, who does that? You have the CPU scheduler. CPU scheduler. Kat sini. Either long term or short term. Okay. Short term. Okay, short term. Short term, you have several algorithm. Banyak panjang ni. Algorithm kita nak masuk ni. Algorithm, it can be either FIFO, tak tahu lagi priority, lagi you have round robin, lagi SDF, shorter job first. Saya teruskan. Sebelum ni. Okay, sebelum ni. Sebelum ni ada preemptive ni. Lupa pula. Preemptive and non-preemptive. This one, algorithm ni dia ada type of either preemptive or non-preemptive. Di sini baru dia pergi sini. Sini. Banyak algorithm, algo, preempt, non-preempt. Kemudian dia ada kat sini dia ada kat sini sama ada FIFO, SDF, priority, robin, ada lagi. Ini ialah PM. Nanti lah saya masuk NCS. Banyak lagi. Demi 2 besar ni. Chapter 2 ni. Lepas ni ada apa? Banyak chapter 2. Seperti saya nak kena go fast. Kena go lah. Okay, non-creative. Sebenarnya ambil nafas sikit. Okay, non-preemptive. Ya? Okay, tak nak take 5. Okay, preemptive. Ya? Preemptive scheduling. Okay? Preempt interrupted. Preempt interrupted. Non-preempt cannot be interrupted. Preempt can be interrupted. Non-preempt cannot. Cannot be interrupted. Itu hafal. Preempt cannot. Preempt can be interrupted. Non-preempt cannot be interrupted. Result, Okay, interrupted by a new process. This is preemptive. Can be interrupted by a new process arrive. Okay, a new process arrive. Ada kat sini kan? Flow. Mana tadi? Panjang-panjang ni. Sini flow ni flow processes ni. Okay, and interrupt or signal occurs. Or based on your clock lah, interrupted kan? Non-preemptive without external interrupt. Once the process is executed kat sini, running ni, it will continue execute until terminated. Complete kan? Okay, this is your processor tadi tu. CPU scheduling decision may take place when the process switches from running to waiting state, switches from running into ready state, from waiting to ready or terminated. Ke sini. Ya? CPU scheduling decision. Ya? Again, I repeat, either preempt or non-preempt. The CPU, your computer will decide when your process either instead of running to waiting. Kat sini CPU scheduler will decide. Ya? Buat decision lah, either to preempt or non-preempt. Okay, from running to ready. Mana dia? Running to ready. Kat sini also your CPU scheduler takes place. From waiting to ready, again your CPU scheduler will take place. Kat sini. And finally terminated. Terminated kat sini end lah. Ya? Sekejap ya ni. Alright. CPU scheduling occurs. Why? The criteria: CPU utilization, the ratio of busy time of processor to the total time of process. Okay, for example, the formula is this, processor by time, ini divide by busy plus idle time. To increase the throughput, number of processors being completed, divide into time unit. For example, 100 process complete within 2 nanoseconds. That is throughput. Turnaround time, waiting time, response time. Turnaround time, waiting time, and response time. Turnaround time to time spent in the ready queue. Waiting time spent in ready queue is wait. Response time is the state of the start responding. Nanti you are going to calculate kat sini. Kita akan masuk calculation. How to calculate turnaround time, waiting and response time. Buat cakap Okay, scheduling. This one you can read types of scheduling: long term, medium, short term. Inilah ya. We have the strategy kat sini. Strategy, we have FIFO, SJF, round robin and priority. SJF Okay. And combine strategies. Multi-level queue and multi-level feedback queue. Combination of, for example, multi-level queue combined with multi-level queue. First in, first out dengan roving. Multi-level feedback queue can be usually based on combination of people and roving with several queues. This one is one queue. Lagi. Okay, any question? No question. Baca dulu. No question aja. Okay, kelompok puzzle. Puzzle. Don't forget to write your name, Saya nak listen. Okay, channel dia Muhammad Afiq.
Saya.
Usna. Izwan. Amirul. Nadia. Arifah. Narini. Nurul Aida. Muhammad Akif. Nurhanani. Asrafullah. Michelle. Muhammad Muizuddin. Nur Syafiqah. Nurul Adila. Azira. Afiq. Fabian. Nur Syahara. Muhammad Hafiz. Muhammad Hafiz. Nur Siti. Ahmad Lukman. Oban. Nur Zafira. Putri Emalisa. Nandini. Muhammad Fikri. Muhammad Najib, Nurul Syifa, Muhammad Zulilmi, Siti Aisyah, Nur Fatin, Muhammad Azrai, Devendran, mana? Iraja, Divya, kita bunyi ya? Anis Waran, Muhammad Amin, Farhana, Nur Hakim, Fatin Manani, Safwan, Khairul Umar, Muhammad Saiful, Hana, Umi, Muhammad Izzuddin, Muhammad Syamizan, Nur Ain, Guru Syahidah, Nuri Zati, Tamila Rati, Ezul Rani, Nur Afifah, Sima, Sima, Nurul Hazimah, Nur Atika, Adri, Sultan, Muhammad Amirul Fikri, Siti Nasuha, Nur Fatih, Nurul Huda, Nur Afifah, Muhammad Zahur, Nur Atika, Muhammad Amirul Hakim, Nur Syahamira, Muhammad Aiman, Afifi, Nur Syazwani, Jackson, Nur Fadli, Limwe Sheikh, Muhammad Fikri, Notika, Muhammad Samir. Okay class, chapter 2 is the last chapter. So I suggest you to buat mind map lah. Yeah? At least you know the point, the relationship between terms lah macam tu. At least when you have the mind map, kau punya mind map tu, you can reflect back what have you learned. Yeah? And it is good if you relate back to chapter 1. Yeah, chapter 1 tu introduction kan. Relate back to the chapter 1. Ada question tak? Saya open for question. Tak tahu nak tanya apa? Tak tahu nak tanya apa? Okay, start ya. Okay, pergi algorithm. Apply where kat sini ya. Apply where dalam projection. Ya. Class, check general algorithm is being done by CPU scheduler. Yeah. CPU scheduler will conduct schedule algorithms either preempt or non-preempt. And there are types. In algorithm there are several types. They developed or found by people like IT programmers or researchers. Yeah. Develop the concept of FIFO you yesterday. First in, first out. Or first FTFS. First come, first serve. Okay, the types here. We have FIFO. FIFO cannot be interrupted. If cannot be interrupted, it is non-preempt. Yeah? Shortest job first. You cannot interrupt. Shortest job first. Shortest remaining time first, it is preemptive. Round robin, preemptive. Priority is non-preempt. Multi-level, preempt. Preempt and also is preempt. Combination. When you say about multi-level queue or multi-level feedback queue, combination with FIFO and round robin, or SAF with round robin. Usually with round robin. Okay, FIFO is the simplest way. Yeah? Based on number. If in a bank, based on your number, processes are dispatched according to arrival time on the ready queue. Kat mana ready queue? Kat sini. New ready queue. Yeah? Based on the process that arrives in ready queue. Yeah? Process that has the CPU that will run until complete, it is a non-preemptive. Yeah? It cannot interrupt. The disadvantages, even though FIFO is simple, it has a lot of disadvantages. For example, long job will make short job to wait. For example, job 1 requires to do around 30 minutes. Yeah, job 2 only 5 minutes. You need to wait until job 1 complete. Then also, job 2 will run kat sini. Sini Rarely used as a master. Usually is combined with other types. Yeah. Okay, for example, this one. All the processes are in ready list. It is new, and after it is created new, all of them are in ready list. Yeah. Everyone is in the bank and got his own number. Yeah. Since A has the number 1 or 001, it will run. Yeah. Dispatch and run. Complete. Yeah. After it is complete, then only B will run. And ada terminated sini ya. Terminated kat sini ya. Complete kat sini. Ya. Complete kat sini. Ya. And after B completed, then only C will run. Ya. Okay, for example, process. We have process P1, P2, P3. We have 3 processes. P1, P2, P3 with the first time or the quantity. Yeah, the length or the length to complete. Yeah, first time. P1 requires 24 milliseconds to complete. P2 requires 3 milliseconds. P3 requires 3 milliseconds. Right? Okay, since P1 arrives first in ready queue, yeah, P1 arrives first in ready queue, so Then uses P4. Yeah. The P1 needs to complete, then only P2 will go next. Yeah. Okay, to calculate, yeah, to calculate the turnaround time, the waiting time, turnaround time, waiting time or response time, you need to draw the Gantt chart. Why do you need to calculate? Because it is in the syllabus. I need to teach you. Okay, Gantt chart. Gantt chart ni planning kan? To plan Gantt chart. Okay, draw the Gantt chart for this table, for example. Okay, if I didn't mention, the question didn't mention the arrival time, assume the arrival time is 0. Okay, if the question didn't mention arrival time, assume that the arrival time is 0. Just start from 0. Okay, P1 will run first after everything are ready. P1 will go to the next stage is run. Okay, complete. Remember it is a non-preemptive. Non-preemptive. From 0, complete at 24. So P1 0 until 24. Betul ke?
Yes.
Why 24? Because the first time is 24 milliseconds. Yeah? Okay, then only P2 will run. Kan? P1 ni dah complete lah. Complete, terminated. P2 will slot in, start. 24 plus 3. Plus 3 equals to 27. Betul ke? Is it true? Yeah, depends on the first time. 24 plus 3 equals to 27. Okay, complete. The next process is P3. From 27 plus 3 it is 30. Yeah? This is the Gantt chart for your job. Yeah? For your job. That one job, a lot of processes. Either in mana paging tadi? Mana paging tadi? Tak ada. This complete. Sini ya. Tadi ni paging, ada paging ataupun segmentation. Ya. Segmentation or paging. Dia punya one main job with several pages or several segments. Ya. Okay, to calculate waiting time. Okay, what do you mean by waiting? Ya. From ready to run. Ya. From ready to run, people, your job or your process need to wait. Kan? Ready to run. We have the number. However, you still need to wait. Waiting time for P1. Yeah? Waiting time for P1 if they ask you to calculate waiting time for the this job. Yeah, this job. You need to calculate first waiting time for P1 equals to 0 milliseconds. Why? Why? Start from 0 and it is in the right process. The right first 0 millisecond minus start from 0. 0 minus 0. Jadi 0 lah. P2 24 milliseconds. Why? Because start from 24 arrives at 0. Yeah? P2 start from 24 milliseconds arrives at 0 milliseconds. Yeah? P3 start from 27 milliseconds. is ready queue at 0 milliseconds. That's ready. This is a perfect stage, yeah. Ready and run, yeah. Ready and run. Okay. Before everything arrives at 0 milliseconds. So P1 is ready, P2 ready, P3 ready. Yeah. P1 ready, P2 ready, P3 ready. Yeah. Okay. P1 runs first. Then it will run at 0 milliseconds, complete at 24. Yeah? The number 24 depends on the burst time. Okay, P2. Yeah? Remember, P4 is 9 preamp. Needs to complete. Yeah? So P2 will start from here until 27. Yeah? Okay, complete. P3 starts from 27 until 30. Alright. So, waiting time for P1. This is 0. Yeah, this is 0. Yeah, 0 milliseconds. Starts at 0. Runs in 0. Again, waiting time ya, langsung nunggu. Yeah, this one at 0 millisecond, it is already being executed. Then, start, run, execute at 0 millisecond, runs when? 0 millisecond. So, waiting time for P1 is 0 millisecond. Waiting time for P2, mana? Dia runs at 24 kan? Runs in 0 milliseconds. So, P3 27 start being executed at 27. Rise when? 0 milliseconds. Yeah? Okay, dapat tak? Let's start this one. Who determine the ready queue ni? Memang inside the CPU scheduler lah. Ya? Okay. Any question anyone? At the back? What are you doing? Boleh. This one? Any question? Cloud. Average waiting time. Average apa in ni? Rata ni ya. So, is average campur semua ni divide by 3. Berapa ni? 51 divide by 3 Okay, this is waiting time. Ada tak? Okay, waiting time. Okay, this one turnaround time. Yeah, turnaround time. Turnaround time ni mana? Turnaround time. Turnaround time, the sum of time spent in the ready queue, execution time and input-output time. The formula, the formula for turnaround time plus process completed minus process submitted here in ready queue. Turnaround time, process time, time of process completed minus process submitted. Submitted kat mana? Di ready queue. Ready queue. Okay, for this turnaround time for this process, okay, P1 turnaround time dia 24. 24 submitted 0 equal to 24. Okay, P2 complete 27. In ready queue 0. P3 30 complete, complete 30. In ready queue 0. Okay, and average turnaround time berapa? Total P1 plus P2 plus P3 divide by 3. Why 3? 3 processors. 3 processors. Berapa ni? 11 5 5 6 7 8 bagi 3. Berapa? 81 divide by 3. 27, 27 millisecond. Turnaround time. Average for each job complete, by using P4 algorithm is 27 milliseconds. Average for each process to wait by using P4 is 17 milliseconds. Wait for 17, then only can run. Need to the time to complete everything is 27 milliseconds. The average. And another part is response time. Response time. The amount of time it takes to start responding to a request. First response minus submission of request. In our case, waiting time and response time for P4 will be the same. Response time, remember, start responding. Start responding to a request. Okay, for P1 start at 0. In ready queue 0. P2 start at 24. Ready queue 0. 24. P3 start at 27. In ready queue 0 and 27. Okay, response time for everything and average. Response time they doesn't ask you. Normally they doesn't ask you to calculate the average. If they ask you, then just divide by 3. Just everything. Response time. Why is it important to know? For response time. At least you, the developer or the developer or the programmer can estimate which type of algorithm suits for a server. For a server. Since server will receive many jobs or many activities, so that's why the developer needs to think, or the programmer needs to think which algorithm suits for a server, which algorithm suits for a PC, for a laptop. which algorithm suits for a handphone? Yeah? Depends on the processor, the capacity or the performance, the processor performance. Round robin ni next week somebody asked me round robin apa? Pasti robin. Robin you need to wear pink kan? Once kena say kan? Betul tak? Tahu? Tak tahu? Kena pergi? Robin? Tak, kopi nak rasa. Malaysia yang rasa. Okay, kasi kopi on Wednesday you need to wear at least one benda lah pink. In pink colour. Okay, back to the Bang Robin dah punya. Bang Robin, I want you to assignment, but you don't have to submit. This is your task. Please read everything. From part 1, part 2, and at least you look at the slide. The slides are in the CDOS. Please read. Bang Robin, there are terms that you need to understand. Okay, before I end this class, any question on this one? People. Okay, any question at all? No. Tak boleh. Guna people. Kalau guna lain, kalau SDF tu boleh. Thank you, Apa dia? Cik lah, baru sama. Ada? Satu mana? Bawa nak? Bawa.